of research and how is it going on?
It's been about 1 year since I've been here. I do have some progress. So the research basically deals with what is known as fracture mechanics, which basically talks about how materials break.
Okay.
What we are interested in is interfaces.
Mm-hmm.
So usually your fracture can occur in a number of things which you see in your life, that may be railway tracks or maybe even aeroplanes, things like that. But what we are specifically interested in is when interfaces fail. So for example, if you have some sandwich structure in which you have material 1 here, material 2 here, when will this interface fail? How strongly does this adhere? And even if this has started failing, how long can it go on without basically causing loss of life and things like that, reliability, things like that, basically. So yeah, my research basically focuses on these questions, on how materials break, basically, broadly speaking. Yeah.
So when I have gone through your profile and all, your profile was written that you are in applied mechanics and physics. So what exactly the physics research you are working there?
Right. So I did not say my research is in applied mechanics and physics. I said I model phenomena using tools from applied mechanics and physics. Okay. So, for example, I'll give you an example. In mechanics, what we do, we usually have a macroscopic view of things. Like this is a block. I apply a force, what will be deformation, and so on. Now, in the recent example that I gave of the interfaces, let's say I have an interface and there is a glue in between two surfaces which is holding them off. Okay. Now, if the surface starts breaking, and okay, one thing is that you can say at the macroscopic scale that okay, if I apply this much pressure, the bond is going to break. But what we can do is we can study things at the microscopic scale also. Exactly. We can go down and say that okay, these are bonds, and then when this number of bonds will break, the interface will go on. So this statistical study in which you study bonds and how they basically accumulate to give the macroscopic results which you have. Exactly.
It's basically molecular dynamics and all.
Basically, going from molecular dynamics to higher and higher scale. So these are the things where you can require physics. In our research group, we use whatever tools are available. We'll do experimentations, we'll do molecular dynamics, we'll do different things we have to basically get to our main goal, which is to study the failure of materials. So after you come in, which many PhD students maybe don't pay so much attention to, is to also take care of the breadth of your knowledge and just don't go deep, go wide also, basically. Definitely, after the PhD, you are expected to be the world expert on your field. You are expected to know even more than your advisor in that particular area. But just make sure that you are not limited to that. You're not limited to this. You have some width with you also, so that switching topics becomes easier. So, and how do you gain that? You attend talks, you attend seminars from people who may not be directly in your area of research, for example. Okay. So if I get to see, okay, there's a seminar notice, I can go there, I can go there, but the area is not directly related to mine. You would still go there and see what people are up to. Maybe it will give you a spark, maybe some ideas you can pick up. On similar lines, you should try to take many courses. After your PhD starts, you may not be having a lot of time, but I think one course each semester you can definitely take and try to explore, try to go to different departments, take those courses, basically expand your knowledge, expand your arsenal, so that when you've got to shoot, you have the tools for it. Okay. So yeah, just be very holistic. Obviously go deep, but just keep on looking what people are doing left and right.